Um, Hi everyone, I'm Andre. I am an intern at Vector on the Applied AI Design and Delivery team. And so today I want to talk about one of the projects that I worked on around diffusion models, specifically focused on tabular and time series data. So we'll cover a few things today, starting with like an introduction to synthetic data, which is what kind of diffusion models were leveraged for within this project. Then talk about why diffusion models. And then I'll want to go into a little bit about the project itself and my role within that project. And then close off with some of the applications of diffusion models that we saw at the end of the project that the teams did. So quick intro to synthetic data. We can kind of see that with a lot of these companies that are building these massive large foundation models, they're starting to run into issues where they've downloaded essentially the whole internet. And now at this point, it's like, what else do you have to train your model off of? And it's not only companies like this where data quality and data accessibility is an issue. It's not only the Googles and the Metas. It's like every single company kind of runs into some sort of issue like this. And so this is just some data from the US, where it says around $3.1 trillion is the negative impact of bad data for US companies. As well as 12% average revenue loss for these companies. So incomplete bad data, access to data. This is a massive problem, and especially with AI becoming more and more prevalent in our data, it's only going to get kind of like a larger issue. And so synthetic data has a possibility to kind of fill in these gaps. So Gartner estimates that around 50% of the data used in AI and analytics projects will be synthetic data by 2030. The second-hand market for synthetic data is small right now, around 300 million, but expected to grow at a 35% CAGR. And that's not kind of like the only place we're only going to see kind of secondary synthetic data out there. We're actually going to see that a lot of companies are investing internally in synthetic data. And so organizations, a lot of the hyperscalers are doing this. NVIDIA has created a model where companies can go and create their own synthetic data and made that widely available. Microsoft and Meta have each used synthetic data to create smaller task-specific models where they may not have access to a large amount of the data for that specific task. And so, yeah. Then why diffusion models for synthetic data? First, I'll start with a little bit of history about like how diffusion models came around. Diffusion models, their history comes from physics, and originally the equations were from modeling out the diffusion of material from high concentration to low concentration, such as a drop of dye in a glass. By the 90s, we saw that these models were then used to, these equations were used to, on applications such as reducing noise on images. And then fast forward to the 2000s, we see that these models have gotten complex enough that they're now generating images. Companies like OpenAI and Stability AI are creating image generation models, as well as they're being applied, of course, to a variety of other use cases for synthetic data generation. They work in a two-step process. The first step is kind of like adding in noise. So you start out with, for instance, an image of a cat, add in some noise to the point where it's just complete noise. The second step is you reverse that. So it's the generative process where you're saying, okay, now that we have the noise, how do we get the image of the cat back? And then once you're able to do that, you kind of get rid of the first step. The second step is the generative model. So diffusion models are good for a few reasons. They aren't the only type of generative model for synthetic data, but they're very good at creating realistic results and capture like complicated patterns. And they're very reliable and steady. They provide consistent results, which is obviously fantastic. The cons being that they're slow and demanding to run, and then they're quite difficult as well to set up. You need kind of specific expertise. They have complex hyperparameters, things like that. And so we see that they have a strong place. They perform well. This is kind of a 2x2 of complexity and ease of training. They do perform well. There are other models out there that could kind of perform format if you're looking for, say, ease of use or something like that. So now going into a little bit of the project and my role. So the project was you focus on time series and tabular data. So how do we leverage diffusion models to kind of create synthetic data? Essentially we had over the span of around 3 months, kind of split it up into a few sections. The first section would be the registration process, where I was very heavily involved in kind of creating the marketing materials, call for participation, and kind of getting having meetings with a bunch of teams from our sponsors and seeing if they're interested. Then, once we kind of got the sponsors together who were interested in working on this, we had our technical lab, which was an educational session, which was very cool to kind of be able to kind of sit in and understand what these models are capable of, and see how the teams are kind of playing around with these. And then in between the technical lab and the boot camp itself, we had a few weeks where we worked with the project teams to kind of identify specific use cases that they want to go after, set the valuation criteria, make sure they have the data available, and that they're ready for the boot camp where they actually applied their knowledge then to kind of sussing out their use case and turning that into a proof of concept. Worked with a fantastic team. Not everyone's here, but these are kind of the core team members. So project management team, Umar and Eric were kind of leading this. So a lot of work hand in hand with them, as well as Baran, who was a PM intern as well on the team, and some fantastic people on the technical side, engineering side. Sana was kind of leading this along with her team. We had 10 companies, kind of from different industries, but very heavily focused on banking and consulting, and kind of the use cases that came out of that were indicative of that. And until we had 56 participants, from those 10 companies, it came up with 11 use cases. So we got quite a few interesting applications out of this. So getting into the applications themselves, one of the first tasks that I was asked to do was kind of do some research into what diffusion models can do, so we can figure out what do we want to offer during this bootcamp, and kind of split this into three things. One is how do we improve data quality? So diffusion models can do things like data augmentation, adding in additional data to make sure in case you don't have enough data to train a model. They can also do things like noise reduction and signal enhancement by focusing on a specific type of data. They can help with make data more fair and more unbiased, such as imputation of missing data, so making sure that all parties are equally represented, as well as handling imbalanced data, and then privacy protection. So can we create synthetic data that is kind of shows that is very similar to the original data set, but isn't the same, so that we can kind of share that data around. From this, we came up with the following these were the applications that we looked into during the actual lab, and they were primarily around, as we said, tabular and time series data, but focused on things like generation. So can we generate whole new data sets? Imputation, can we figure out missing values within the data sets? And then forecasting. So actually, can we forecast future values? So we saw that the most as we can kind of assume, the most interesting techniques were around synthetic data generation and imputation. Though a few people did look into things like anomaly detection and forecasting. And then we saw that though the techniques were kind of standardized, we saw that there were a huge variety of use cases. People were looking at things from, can we use synthetic data to improve a marketing campaign, to can we develop models? Overall, we kind of saw two high-level themes, which is one, synthetic data generation for improving a downstream model, which is kind of what the majority of our teams looked into. And so an example of this was a telco that would impute missing customer data fields, and then they would use that to be able to run marketing campaigns. And then the second one is leveraging diffusion models for the actual downstream end use case. And so an example of this is forecasting like currency valuation trends on time series data. And so these models are quite flexible and usable in a variety of different ways. And yeah, so just to wrap it up, synthetic data is going to be extremely important in the coming years, as we can see, as not only in creating additional data, but also improving existing data sets. Leveraging these models can help improve data quality, ensure fair and unbiased data, and provide privacy benefits. And synthetic data generated by these models can be leveraged for like a variety of downstream use cases. Yeah, so that's my presentation.
Any questions?
One great presentation, firstly. And so I guess one thing I was wondering is, I understand you mentioned the telco case in the last slide. There's missing fields, and so you can make the predictions of what the fields are and then use it. But I'm curious of the other, when you talk about, like, let's say you want to make a prediction of the people in this room, but we're not a lot of people, so you create a bunch of synthetic people. Isn't it though you're still using the same patterns that people hear? So like, does it really get a better prediction? Like that to me doesn't make sense, because it's still the underlying patterns of the data, limited data you have.
Yeah, no, I think that's a pretty heated debate within this area as well. So I'm by far not the most kind of like the person who's probably the most equipped to answer that. But from what I can understand, one, for some reason, like in a lot of instances, it does work. So, if you just take the output of a model prior to using synthetic data and like after, then the like certain metrics just do improve. And then it gets into why does that happen, right? And I've seen kind of like a few use cases of that happening. Why does that happen? I think when if the model is able to capture like underlying trends in the data, it may create instances that don't exist before that overlap to multiple underlying trends, which in itself, if that's a realistic instance, could create like a new kind of form of data. So that's kind of like from what I understand. That being said, it really is kind of like a tinkering project, and that's kind of what we were doing here, which is test it out. If it works, like that's fantastic. If not, like you probably have to play around with it like a little bit or try something else. Yes.
You go.
Oh, sure. A really quick question about like why I noticed that you mentioned there are like two areas. There's time series and also tabular data. I wonder what's the reason behind those two areas? Like, is there any reuse of techniques between the two?
Yes, I think the focus was, so typically these models in like the most popular or well-known use cases around image generation. I'm sure you know like stability AI and stuff like that. We focused on tabular and time series because a lot of it was really demand driven. Like a lot of the participants, the companies were in companies that leverage tabular and time series data a lot, like banks and consulting firms. So that was kind of like more demand driven. Sorry, and the second part of your question.
Oh, just wondering if you were able to reuse like techniques or material between. I might have misunderstood this part, like doing tabular time series data, not just like time series and tabular data.
Time series and tab, yeah. So we had multiple different. These are kind of like different use cases or different applications, and so within tabular we had single table generation, single table imputation, multi-table generation. Each of these we kind of use a different technique, CSDI. I'm not going to name them off right now because I don't remember all of them exactly, but different types of models that could tackle each of these and a bit more specialized, all different types of diffusion models.
Just wondering, how do you bridge the two? Because there seems to be some kind of this separation.
So I think it's tabular. You asked like tabular data is essentially time series data without a timestamp kind of thing. So if it had a timestamp, that was I believe it had to be like a regular interval or something, or if it had a timestamp, then it was considered kind of time series. But if it was not timestamped, then it's more going to be like tabular data.
Makes sense.
be quick, I know we're over time. Okay, so you've been here for over almost a year now, with your
Yes.
internship. What skills do you feel like you've learned over the last year that have helped you prepare for this project? Or do this project?
Yeah, I think over the last year, what the thing that I took away mostly from like my vector internship is being able to speak at least enough about the technical stuff that it sounds convincing. So I hope that was apparent in that. And I think that like for this project, during the initial kind of chats, it really became evident that was gonna be important because it's a bit of a technical project. We're talking to technical teams, and so being able to like understand what they're kind of like looking for out of this, especially as we're kind of going through this exercise to understand what to offer, I think was quite useful.
Thank you.